All right, so let's go ahead and get started. So, just like we've done in the past, if there's something up here that's not on your notes, write it in. We'll get you a 5 out of 5 on this, so you can hopefully improve your grade a little bit before the end of the quarter. Yeah. So, Chapter 8 is about linear regression. All right, so we're going to focus on the linear model. All right, now the one that we used for finding our correlation coefficient last week, make sure the sound is on here, otherwise it's not going to be fun. All the way. The one that we used last week gave us our letter R, and we had our A and our B, which is going to give us our y-intercept and our slope. Okay? So the idea is the linear model is going to give us the best idea for the linear relationship between these two variables. Okay? And what's really nice is that the computer will spit it out for you. Your calculator will tell you, so you don't have to do any of that work. All right? Because we could, by hand, figure out the best linear model, the best line. All right? But this class is more about interpreting that line as opposed to finding it. All right? That's what we're going to focus on in here, interpreting what the model's telling us. So the first word that's going to come up a ton is residuals. Okay? So you already heard from me a couple weeks ago that all models are wrong. All models are wrong. All right, but some of them are useful. All right, some of them are useful, and we will use them. All right? So no matter what model we pick, or what model that the computer tells us, it's not going to be perfect. All right? There's always going to be something that's not there. And so what we focus on is called a residual, and this is the difference between what is observed in your y value. All right? So what your actual y value is, and then what the model predicts it to be, that difference is called a residual. All right? So it is an error. It's not percent error, it's error. It's not R. R is the correlation coefficient. All right. Now, when I write the word error, most students have a negative connotation with this word. When I write error, your brain thinks, not good. Right? But in stats, error is okay. It's expected. It will happen every time. And we're going to look at it. All right? So just because you have a difference between what your actual data is and what your model predicts it to be, it's not a bad thing. All right? That is part of a model. All right? If we can minimize this, then our model will be more useful. Okay? So that's what we're going to do in stats. Any questions so far? Man, I don't think it's going to get better than that. That was really good. Nice lecture, me. Good job. All right. Tough crowd today. Best fit means least squares. So you're going to hear a lot of ways to describe this linear model. You're going to hear the linear regression model, the line of best fit, the least squares regression model. There are a lot of things in here that we're going to say that mean the same thing. Okay? So the reason that I wanted to put this here, because even though we're not going to ever calculate it, is that each time you ask your computer to find the linear regression model, it's going to do its best to minimize that error that I mentioned on the previous slide. Okay? So it's going to do its best to minimize the distance, to minimize the distance between your actual data values and the model. So if you hear me talk about the line of best fit or the least squares line, all that means the same thing. It's your model. Now this next section at the bottom is a little tougher to explain, so I'm going to do my best. Okay? You guys remember in middle school or in algebra where you talked about slope. Okay? So if I move in the x direction and the y direction, that gives you your slope. All right, or whatever order you want to go. All right, your rise over run. So when we talk about the slope for our line, we're talking about how if we move in standard deviations in the x direction, then we move a similar distance in the y direction, we always multiply it by our correlation coefficient. All right? And you learned last week that r is between -1 and 1. And usually, is it going to be -1 or 1? It's not, right? That's going to be uncommon. Okay? So if we multiply something times a value less than 1, it's going to decrease. All right? So this idea of your model calling the regression line, it's because whenever you move in the x direction and you move in the distance to the y direction, you're not going to move as far up because you're going to regress towards the mean with that multiplication. If you don't understand that, that's okay. All right? We're going to talk about a lot more. And also, if you do anything in college with stats, we'll talk about this again. All right? You might hear it if you're watching something on TV, talking about the regression to the mean. This is what they're referencing. Okay? All right. Let's keep going. Now, here's our actual regression line. So I'm going to circle this, because this is what we're going to get when we actually have our regression line. So I want Joseph to put your hat on. He is now predicted Joseph. Take off your hat, Joseph. That is observed Joseph. That is actually Joseph. Put your hat back on. That's the, oh, no, that's the regular way. Don't want to confuse people. There's only two ways. When you see a hat, that means whatever you get is going to be predicted from the model. So right now, when I look at Joseph, he is predicted from our linear model. And when I say hat, I'm talking about this little symbol right there. That means predicted. Why hat? You can take off your hat. Thank you, Joseph. I appreciate you. Thank you for bringing that. I know I emailed you last night, so thank you for doing that. Exactly. I just saw his hat and figured, why not, right? See, I'm crushing this lecture. Subscribe. Okay. Now, the calculator will give you A and B. Okay? A is your y-intercept, and B is your slope. Now, why is that confusing? Are you used to what form? Y equals mx plus b, and b was your y-intercept. Now, what is your b? Your slope. Okay, so that's going to be a little bit of a change. All right, and those of you that are only in statistics, all good. Don't worry about that. Those of you in calculus or pre-calculus, you're going to have to worry about knowing the difference. Okay, you'll be fine. All good. Say it again. So we're not going to use slope-intercept form. We're going to use this form. That's the y. But again, it's predicted. Okay? B is the slope, and A is the y-intercept. And again, this class is more about interpreting what those letters mean, okay, than actually being able to find them, because the calculator will do it for you. All right. So I gave you an example right here, Marcel, if you want to look at an example. They're in the chapter that you guys all read, because I'm sure you already read chapter 8. They had an example about looking at different sandwiches and burgers at Burger King. All right? And so it talked about the relationship between how much protein is in that sandwich or burger and how much fat. Both are measured in grams. So you can see that there is a positive, linear, moderate association between these two variables. So as we find sandwiches that have more protein, we expect what to happen to their fat? Increase. So if you look at this model, if I plug in, like say I go and I get a burger and they tell me it has 18 grams of protein, the model can tell me what I expect the grams of fat to be. Okay? And if it's a useful model, that prediction will be close to the actual value of fat. Yes?
So that's how you can find outliers?
What do you mean, how you can find outliers? I see what you're saying. Are you saying, like, if you plug in an X and it gives you a predicted Y that's really far away from the observed Y? Yes, something's going on there. Okay? Because hopefully your model, because again, you see the thing in red? It's trying to minimize the distance between all the blue dots and the red line. So let me give you an example. I'm going to use orange. You good with that? Oh, no. I'm going to use whatever this color is. Is this red? Great. Red. Look at this line. Do you see that line? I'll try my best to make it a little different, but close. If this is the model, this one, you see this dot here? That's closer to my line that I drew. So that line is actually better for that dot. Okay? So the computer is figuring out what line is going to minimize the distance between all of the dots, not just like one or two. Okay? So that's what the computer is doing. So like you guys could sketch your own. You could sketch your own. Okay? But the computer's like, haha, that's nice. They're going to calculate exactly what the best one is. Okay? We're not going to. Computer will do it. Yeah?
And what's the black line?
The black one is just to show you from this. I ripped this from the book. It's saying that it was actually the best sandwich that Burger King used to have, but sadly it's gone. It was called the BK Broiler. I don't know why everyone laughs when I say it. Every year, some person, some student, Tanya, they chuckle because as if like, what's funny about that?
It's so random.
It's delicious. My brother and I would go all the time to get it. I'd be like, I come home from school. Hey, Peter, BK Broiler? Yeah, let's go. We just go.
Oh, that's why they went out of here.
George, funny. Yeah, George. Remember George? Okay. So this BK broiler has, I think it was like 30 grams of protein. So it's telling you right here is where it's expecting the total fat to be. That's why that's there. So when we do it, that won't be there. Okay? All right. Now, you guys, we've been doing this for a while now. And you know before we do anything in this class, we got to check some things. Okay? You're going to see that the conditions are actually the same that we checked with Chapter 7. We still need to make sure that we have quantitative variables. Does your scatter plot look linear? And as Tanya is asking, Tanya V has asked, we need to make sure we check for any possible outliers or unusual features. All right, if all those things are okay, then we can proceed to run a linear regression model. Yes, Roberta.
First, you gotta check if it's correlated, then we do the regression model.
So basically, do you remember the checks we did to see if we could use the word correlation?
Yeah.
It's the same checks. All right. If you're all good to use the word correlation, then you're all good to run a linear regression model. Okay? Everybody okay? All right. Bless you. Now, this is important. And it's definitely 100% going to be on the AP exam, guaranteed, or your money back.
How much?
Well, you're not paying for it, so no. So, whenever you do a linear regression model, okay, I want you to look at this right here. You have your data, so your scatter plot. You have your model that does its very best to model the relationship, and then you see this residual, that's the error. Again, is that bad? No, it's because the model will not fit it perfectly. Okay? There will be stuff left over it couldn't model. That's okay. It's doing its best to minimize this, to make it as small as possible. We need to look at the residuals. All right, so I'm going to show you today how to look at the residuals. And if there's something going on in there, then we need to stop doing a linear regression model. It's not appropriate to continue using it. Okay? I'm going to repeat that. We're going to check the residuals plot. And if there is a pattern or something going on, then we are going to stop. And we're not going to use this linear regression model. Okay? Now, if you check it and there's nothing going on, there's nothing there, it just looks like a cloud, nothing, go ahead, use the linear regression model. Okay? Now, some of you might be thinking, okay, well, what if I find something? Great question. Chapter 10. All right. Great. Any questions? One more slide. R squared. And one of you mentioned that R squared was in the output from our TI Inspire last week when we looked at the correlation coefficient. R squared, and I don't like to use this much, but I'm going to say it. R squared can tell you how good, let's put it in quotes, how good your model is. I usually don't like to say that because you guys know that all models are wrong. But the closer your R squared is to 100%, the more confidence I'm going to have in using it. If you have an R squared that's close to 100%, that means your model is explaining this relationship very well. If your R squared is not very high, if it's close to 0%, that means there's a lot of other stuff out there that is making this relationship happen. All right, and we'll go into the statements you need to write that, again, guaranteed will be on the AP exam, the statement about R squared. All right, nice work. I'm going to stop this.